Friction. Let's say you want to slide a heavy box of books across the floor. You'll have to give it a certain minimum force to get it going. Once you've got it moving, to keep it moving, you don't have to exert that same amount of force that you had to get it started to begin with. What if you want to take some of the cargo out of the box? Then you have to exert even less force to get it going. And this will be all explained in this section, friction. When a body rests or slides on the surface, we can think of the surface as exerting a single contact force on the body, with a component perpendicular and a component parallel to the surface. The perpendicular component is the normal force, and the component parallel to the surface is the friction force. The normal force is denoted by a small case n. The frictional force is denoted by a small case f. The kind of friction that acts when a body slides over a surface is called kinetic friction. Kinetic for motion. And the magnitude of this kinetic friction is going to increase if the normal force increases. That's why if you put more cargo in your box, it's harder to push. The magnitude of the kinetic friction is proportional to the magnitude of the normal force and can be approximated with this equation. The magnitude of kinetic friction equals the coefficient of kinetic friction, and this is a function of the materials used, times the magnitude of the normal force. And recall, this is for kinetic friction, when your object is moving on a surface. Friction forces also may act when there's no relative motion. Once again, if you try to slide that box across the floor, the box may not move at all because the floor exerts an equal and opposite frictional force on the box. This is called the static friction force. And how does this work? This static friction force is going to be less than the critical value, which is going to be equal to that coefficient of static friction times the magnitude of the normal force between the two surfaces. There's also the coefficient of rolling friction. And we know it's a lot easier to wheel a loaded filing cabinet across the floor than to push it. That is because of the coefficient of rolling friction. This is defined as the horizontal force needed for constant speed on a flat surface divided by the upward normal force. Some typical values are 0.002 to 0.003 for steel wheels on rails, i.e. a train, or 0.01 to 0.02 for tires on pavement, which makes a train much more fuel efficient than cars or trucks or vehicles on pavement.